Hello friends, Rashid here. So thanks so much for joining. So this video is about giving you an overview of the 7-day system Verilog challenge that I will have from October 6th. In the first part, I will give you an overview of what kind of circuits I will cover in those 7 days. And in the second part, I will give you a sneak peek into our day one, the very first circuit. That's to give you an idea of what kind of activities I will have. The day one planning, I've done it. I think I'm gonna add some more things or shuffle few things, but I can still give you an idea of what I'm thinking so that you can get an idea of what are the things that I'm going to cover and if this is a good fit for you or not. A lot of people have already signed up, so thank you so much to those. I've been watching your sign-ups. I haven't sent any email confirmation yet, but in a day or two, those will be sent out. So stay tuned. Many people have already paid, so if I give you this overview and you feel that is not a right fit for you, I think it's okay. I can refund you, but after PayPal transaction fees and all that, and there isn't much left. So I think what's probably best is I can keep if you don't want to join after this overview. That's okay. That money that you paid, I will keep it for future challenges. Okay, fair enough. Want to say a few things before I go into these circuits. I know you're watching on these circuits and already looking into it, but I have few important things to mention. So please pay attention. So first of all, this is not. I changed from Verilog into System Verilog. I forgot the name, but somebody had a comment on my LinkedIn post that it's better if it's System Verilog. It's latest and more up to date. I agree with that. So I take that input. Thank you so much for giving me that feedback. And that's what all this is like. You guys engage in this will give me more ideas, something different, and we will together turn this into a nice training. And this is my first time doing this type of thing. And trust me, before doing a regular YouTube videos were difficult because I was not into habit of that. But once I'm into that, I think I doing even daily videos is not very difficult. I really enjoy that. And I have a process in place and all that. And the day I don't create a video, I feel like I'm missing something. And then I was thinking, okay, instead of, I could have done the YouTube videos every day instead of doing a challenge. But trust me, I think challenge will bring a different challenges. And the cool thing about the challenge is we will come together and do some live interactive work. Because I tell you what, I gave you overview of different components within combinational circuits, sequential circuits, but trust me, just by watching the video, you feel you're learning. Yes, you're learning new things, but you won't learn it until you practice it, unless you implement it. Because when you start implementing, you will see, oh, yeah, I thought I knew it, but I actually don't know. So you need to go back and look into it. And using Verilog is a way of implementing those simple circuits that we learned during combination and sequential. So it gives you opportunity. Think of that. It's a tool where you can, instead of in the olden times when you bring those boards and buy those NANDs and put them together, now we can do those things using a Verilog, and it you can see on simulator. And when you see actually waveforms changing, that gives you a feeling, yes, you have implemented something. So I strongly encourage you, whether you take my training or not, uh, on your own time, practice these things in Verilog, VHDL, System Verilog, whatever it is. That way you will remember these things. All right, that's the first thing. So I change it from System Verilog. Practice is important. And in this other thing I found, okay, even for myself, when I just watch video series, it's hard to push yourself in a discipline to watch everything every day certain time. So this whole idea of this challenge was There is an accountability. Yes, you pay a little bit money, you come. I am also accountable that I come, I prepare these things. You guys come in, we do it together. So you for 7 days, you kind of push yourself in a discipline to do this and to accomplish that. Then, yeah, I mean, I'm doing it first time, so I'm sure there will be new things that we will learn through. Each day, I will learn something new, and I will try to fix things on the next day. I picked these 5 combination circuits. The idea was, okay, what are those simple 10 circuits that I pick that are key thing in our learning of combination and sequential, and will be key learning from those when later on we build our CPU or processor. And also I picked the circuit in such a way that you get to learn most of the constructs of system Verilog, especially the hardware related. I mean, now the all the test benches, we will do test benches by the way, so that is an additional advantage of this challenge. But here are the circuits that I came up with. We will start with a multiplexer. We will also do a 4-1, and we will also do each one with a different. Anyway, I'll show you later on. So this is the sneak peek I have later on in the second part of in today's video, and I'll show you that. So stay tuned. Wait for that. Second one, I thought one of the adders would be a good one. We will implement that in System Verilog. A comparator circuit is very important. You have seen from my combinational videos that it's used here and there. Then a priority encoder and a decoder. So very simple, right? We all know them, but again, implementing them in Verilog will give you good practice of different constructs of System Verilog and simulations. Then in sequentials, okay, flip-flop, again, very important one. Maybe within flip-flop, we can look into latch as well. I haven't thought about that. Shift registers, counters, simple finished state machines, and a register file. Simple thing. And I believe as a combination of these, we will cover a good bit of system Verilog. These are simple ones. So if you have already done those, and you feel too simple, let me know. But a lot of people in these trainings are starting from the basics, so I have to think about those, and I'm building my training as if nobody has prior knowledge. Somebody comes from after 12th grade and goes through these trainings and able to learn entire IC design in few months or a year, at least the basics of it. May not become an expert on it, but the basics are good, and basics are really where I'm targeting. All right, so these one, yes, total are 10. We have 7 days or so. I probably need to combine a couple of circuits. We'll see. All right, this is it, day one, and I will do it quickly. I've already tried all these codes, by the way, for you. These are the, let me go to this one. So we will use this EDA playground. I honestly didn't know about this. So I was looking for, okay, what is the free simulators where I can load, and we can create circuits, and we can test those circuits, simulate those circuits. And then there are free simulators, but then I came across this playground, and those are things I was in the industry. I never knew these type of things. It's been a while, so but it's a good, and maybe all of you know about it, and it was just myself. But in here you can see that we can I will show you during day one how to load it. So this is our design multiplexer using just those gates. I'll come to that in a minute. This is the test bench. I will provide you these as a sample files, and then we will go through each line, and then I will give you some exercises where you can change and tweak some things together in a group. And here you can see that, okay, the simulator, I picked this free version, and we will also view the waveforms. So this is the environment. You don't need to install anything. It's a browser based. So you go to EDA Playground, you can already start playing with it. And we put simple circuits, designs, and test benches here, and we'll start simulating them. Okay, sounds simple. I mean, each day we will have 1 hour, so we don't have that much time anyway. So here is what the exercise is like. This I put kind of things together that we will do for on day one, and let's see how much time we have. The things that we don't get time, those will go to you as a homework, and next day I will ask you. So it's kind of putting you, not taking too much of time. All these are very simple, trust me. So for example, the very first time we will create a multiplexer, 2 to 1 multiplexer using just the basic preliminary gates and or invert. And then we will create a test bench for that. Then we will start adding some delays, those hashes thing. Okay, change the inputs and see what's really functioning properly or not. We will view the waveforms as well, and we will practice few things. Okay, what about viewing special signal on a certain signal or certain signal within a hierarchy, and we will talk about different hierarchies as well. Then what we will do is we will next go to the next level. We will implement that multiplexer using an assign and this question mark type of syntax. Then we will practice multiplexer using an if else. Then we will practice the same multiplexer using a case statement. And we will then modify this 2 to 1 to be 4 to 1 max, and we will use using case statements. Then we will look at the worst state. If we don't use default, what can be the problems with it. Then we will build a 4-bit wide 2 to 1 mux. Then we will cascade 2 to 1 muxes. Last two things are briefly I will go over very quickly. Okay, now you want to analyze timing. Okay, the dynamic simulation that we will view, this one way. Another way is a static timing analysis. What kind of timing arcs exist in a multiplexer, and how we will generally create a timing. So not in too much detail. I will cover all these in a separate static timing analysis series or challenge, or just a YouTube series. But here, just to give you an idea from the static timing analysis, how to look at multiplexer. Very briefly, how we do the power analysis. And even if I'm not able to cover, we have more circuits coming in future, we can talk about those. How we use VCD, standard cell, synopsis, PTPX type of thing to measure some or estimate the power of that circuit. So that's really the plan. I feel I don't know how much time. An hour probably be too much, because I will do maybe 45 minutes for exercises, last 10 minutes for question answer, or maybe we will have some 5 minutes within hour for question answer, so that we don't go at the end for question answer. And it will be interactive. You can always ask questions. Always ask me questions. So that is it, and I thought, okay, it would be good based on I've already implemented this in Idiot Playground in different exercises, and I have their answers, and I will help you during the session. But if you look at, I created, okay, what is the unique list of constructs that we will be using during this exercise? So use of logic, then different operators. Then of course input output module definition here. Always blocks, initial blocks, if else, case, assign, and some dump files type of thing. And we will also go into how to define vectors. Okay, how to pass vectors to ports, comments, yeah, the ports and so I think these one pretty much, and even the future circuits you will be using those anyway. All right, so that was the overview of the 7-day challenge, as well as a sneak peek into the day first. Hopefully that was useful. Any feedback, anything, mention it in the comments or text me on LinkedIn. Thank you so much. Have a wonderful day or night. Bye.